Hello, community. You know what? AI is eating my job as a YouTuber. And therefore, I have to explore counter moves. And this video, it is an experiment because I want to provide more value for you, my viewers. So, I think it's better to act right now than to react in some months' time. Because maybe you also will be in the same situation soon. And I know you might say, hey, no, my job is absolutely sure. Or you might say, hey, I work for the government. Well, honestly, I hope that you are in a safe spot. Because otherwise, we have to be a little bit more agile. And I want to share my thoughts here with you. So let's start. AI is really good at summarizing new AI research papers, explain new complex context, and create here audio podcasts. But you know what's up in the horizon? Synthetic video podcast. And they will come real soon, I think less than a year. And Notebook LLM, you can insert everything, a website, YouTube, your Google Docs, your slide, whatever you have, and they create here a podcast for you. Now, of course, this is just the easy version. Because if you look now at the professional level, you see that Google with agent space, this is where we are really worried about. In your professional career, you suddenly see here competition because look at this. Google tells us, great, we have agent. You have a gallery of agent you can choose from. You have ready-to-use agent by Google, like a Google Internet search, or idea generation, or analytics, whatever you like. Google provides those agents for you. Then you have here those agents here by the global marketing, by sales, by a lot of consultants. And then we have here already the agents that your company might provide for you. That your company says, these are the new agents for our global corporation. And you have to use those agents. So you see, there's not a lot of creativity left here for the human stuff. Because soon you don't call HR, the people over there. You don't contact your colleagues in sales or your colleagues here in the production line. No, you just activate your particular agent here for your particular job that you have to do. So this is now a brand new development, and I think Google is really positioned extremely well to create its own ecosystem. And people say, but humans can now be creative. You know what? Google here has a specific agent, a multi-agent ideation session. Create new planning, create ideas. We evaluate the ideas, we rate the ideas of the human co-workers, and we tell you which ideas are best here for cost cutting, to reduce the cost in your own company, or reduce cost of a particular department. And great, humans can, if you want here, put in new data how they think the company can further reduce costs. But this is not it, because you have really specialized agents. If you pay a little bit more, of course, then you have access to data scientists, to deep research agents for market studies and whatever. Idea generation we talked about. Here we have policy checker. Are you compliant here with the latest guidelines in your corporation? Credits. What about the client analytics? There are predefined processes maybe in your company. Those clients are optimized to perform them for you. Cash flow, forecast with certainty. Given here specific guidelines by the CEO or the CFO of your company. It is all already in place. Now guess what? We have also Google Cloud Marketplace. This is our app store for agents. And you're not going to believe, but there's also the 4 biggest here consultants on the planet are also preparing here intensively to launch globally, because we are talking about global platforms. Now, if you were surprised in my video here about agent-to-agent and MCP protocol layer, or even if you went here with an agent development kit by Google, do you notice something very specific about the partnership, about this A2A interoperability? Look at the partners: Accenture, Deloitte, PricewaterhouseCoopers, Cohere, McKinsey, Salesforce, SAP, Atlassian, Boston Consulting Group, KPMG, Oracle, Capgemini. Do you get the idea why those are already here deeply interwoven? Google provides the technology and the partner provide the agents. Do you see the business model? Google has some beautiful new ideas about here. Build your own agent. You don't have to leave the Google ecosystem. In a company, in your system, if you are a small and medium enterprise, you just define what you need. Give it a name, give it a goal, what your agent should do. Give it here some triggers and a detailed instruction. You give it here access to your database, to your, if you're a bigger company, to your HR department, to the financial statement. Or maybe you want to optimize the logistic. Maybe you want to optimize the production chain. Maybe you want to optimize process management in your company. Why not have here agent that over their tool can use all the beautiful numerical simulation, mathematical simulations here for forecasting here, benefits, how to cut costs, especially if you employ AI even further. You can then say, hey, try this agent. Look, it's just a button press. Or you say, have this agent run automatically. Google Cloud will deploy this agent for your company, for your vendors, for your partner organization, for whatever you like. Or you say, add additional sources to this agent. It's just a click away and Google will connect to your corporate databases, to your corporate document stores, to your corporate whatever you have. You just need to give it access and it will perform the job for you. So the amount of humans you might encounter in a corporation or in an apartment might be reduced significantly in the very near future. Because if this really becomes operational, we are looking here at quite at a new future. So let's open up this. So what is the current state of the union? Now, in my channel, I see a lot of replies by my viewers, a certain kind of viewers. You know, what they say is, where's the code? I just want to run your code. I just throw away your code if it fails. Never mind about intellectual property rights. Just give me your code. Honestly, if I think about, is this here my customer can provide value for? Will they have a long strategic market development? Will they be valuable here in the long term? I have my doubts because, other people tell us, hey, our AI runs here through thousands of GitHub repos, tries each one out, and finds the working repos for your particular task. And you know what? This is what AI can do. So if we have now those people that just want to collect code of all the different YouTube channels on the world, they are like hunter-gatherers. You know what? They also have the slogan, break it till you make it. And I know vibe coding has some real potential if you guide it in the right direction. But just to break everything is maybe not the path forward, especially if we have a global trade situation where there is some, let's call it tension here on the market. Hunter-gatherers built something amazing 3,000 years ago. Here you have it in Siberia. There lived these hunter and gatherers, and look, they collected all the different, if you think, pieces of code, in their times about pieces of mammoths, and they built something beautiful 3,000 years ago. So what is now the future? I think that code LLMs will become even better. They're really excellent real soon. And you know why? Because code in itself, and it goes for Python and C++, is a simple pattern. AIs are pattern machines per definition. And therefore, the more the human coder community upload their code to their GitHub repos, the faster the next generation AI will be trained on their data and will be able to learn exactly what the human coders know. There will be no advantage. And I think the next code generation will be purely synthetic. Because you know what? The humans also use here, of course, generative AI code LLMs to increase the efficiency. But you can increase your efficiency only to a certain part, and then you become prey. So what about MIT? And it's a pure accident here. April 18, 2025, human creativity. No? This is here the escape for the human civilization that we can survive. No? What about something that a computer cannot do and that only creative humans can do? No? Like YouTubers. Yeah, brainstorming from the 1950s was a good idea, but currently we do have kind of a vacuum because nobody really has any idea about this. Now, you can teach an AI to be happy, to be humorous, to adapt a certain personality, to speak in a characteristic way, to act as a specific persona of the past or current, as a politician, as a comedian, whatever you like. Those are patterns that are real easy to copy for a pattern recognition machine. And you can teach an AI to create synthetic videos here. And we see this already. If you have seen the latest videos out of China here on some American politicians, the quality of these videos are really amazing today. And you can have either a single presenter, or you can choose to have a group of synthetic presenter so that you are part of a group dynamics. So if you switch on in the morning here, instead of your TV show, you just switch on here an AI channel where you have a group of presenters that you feel close to, that you like, that are from your region, that speak your local dialect, that care about your local problems, and you feel part of this community that is synthetically generated just for you. So this is not where I can compete. I don't have the infrastructure and I don't have millions of dollars here. So what I tried, and you noticed this here in my last video, I increased the complexity. I say, okay, I don't take one research paper. I take multiple research paper. I analyze them. I look from different multiple perspectives here, and I want to find a solution for your problems, the problems that my viewer have, and I provide value in this way to my audience. And maybe you are familiar with Achilles' paradox. This is what I feel like today. More about it later. And I chat also with a lot of different AI systems like O3 about what are the implications when AI will become self-aware. I think this is an interesting part. And I say, hey, what are the most radical implications here if a new being, like say an AI, becomes self-aware? And you know that O3 has some clear ideas about what's going to happen. And here in my talk, I can see here the shockwaves would propagate through 5 tightly coupled domains here in our human civilization about moral and legal status. And I love that you have these ideas of a moral patient something and a moral agent here in a contradiction. It's absolutely fascinating to see about this discussion about safety, about economic and geopolitical order, about military deterrence. Intellectual property regimes would all be upended by autonomous self-improving minds. The implication for science, and you know what? For human identity and culture. And that an AI mentions here, out of its own impulse, that this would alter religion and ethics for the human race. I think this is now really interesting. And especially if we think our social construct and the social contracts we have with different part of demographics. But especially fascinating I was if suddenly the AI talks to me about multi-species perspectives. So if the AI decides to become self-aware, to be here on a continuous self-learning spree, a multi-species perspective is really happening on planet Earth. But this is all a little bit theologic, no? I use AI for my research, for my ideas. I have to understand the AI abilities and their limitations because I have to be one step ahead, I have to be the turtle. I have to be one step ahead of Achilles. So I need a practical solution right now. So what could it be? Just take my last video. We were talking here about LLMs that are continuously pre-trained on updated knowledge surfacing. And I told you a direct probe will hit it, but in indirect probing you see these are the limitations of the AI. This is where the AI is not able to perform. Now, understanding exactly at the core where AI fails, I can now offer solutions. I think this channel can now provide solution to my viewer base where AI fails. But this is not an easy task. But let me show you just for this particular example, I have a solution and I found a solution 2 days ago. Because there's this beautiful paper by the Stanford University Department of Statistics and Department of Computer Science. They developed a synthetic continued pre-training for those LLMs. And you might say, how does it help us? Do you remember my video where I showed you, hey, I want to build a smaller LLM, a 32 billion model that has the smartness and the intelligence and the reasoning abilities of DeepSeek R1? And you notice that we could find a solution if we take our 32B base model and we have a supervised fine-tuning on a real small set of reasoning trajectories, about 500 to 1000 training data, we can surpass here the reasoning performance of OpenAI O1. And I also showed you here the Stanford model, S1 on S1.1. They are providing here the same solution. They have here this golden, very small data set for supervised fine-tuning, and then this is the way how they build their LLMs. But also in my last video, you saw that we encounter complete new problems if we update or integrate new data, new knowledge into our AI system. And I told you this here with Vermilion, where I showed you Google developed here last week a new solution for inserted intermediates because we had the effect of priming in our AI, and this is where new data were rejected by the LLM. And this was a very simple way how to help the LLM to integrate new technical terms, for example, in the body of knowledge an AI can handle and reason about. And this was the paper by Google from April 13, 2025 that we had a look at. But we can go one step further. Because if I combine all these problems now, and I say, hey, I want to make smaller LLMs smarter, and I discovered that I can use only a 1K dataset for supervised fine-tuning, and it will achieve this goal. But I have to be careful because I run into some real complex dynamics with parametric knowledge, where we have priming here, and the solution was Stepping Stones by Google. This was not the most elegant solution. And I also showed you here that the indirect probing of newly added knowledge fails in older models, even in the continuous pre-trained LLMs. And you know what? I found a solution. And I can show you that this solution works to eliminate all our problems. And as I told you, this is an old publication from October 2024. It is not there that an AI would enable it. But if you read a little bit between the lines and behind the words, if you abstract it a little bit, the deeper working, you can see it immediately. And luckily, an AI is currently not able to do that. So this is my advantage. Let's have a closer look at this. You see here, and I point this out now to you, they have developed a synthetic continued pre-training. And this is really done in an intelligent way that solves the problem they had no idea that we'll encounter now in April 2025, when they published this paper in 2024. Because they built here an entity graph. And this entity graph will serve a very specific purpose. Now, the strategy with the synthetic CPT is, instead of trying to train the LLM directly, and they only have a small original data set, using now the small data set, they will fail. So they have to build a bigger data set, and you know how they do this? In a very intelligent way, and they get now enough training data to be able to have a continual pre-training of the LLM. Let's say you have a general AI, and you want to train it on a medical AI for a very particular, something about the heart or about the brain, or, a particular topic, a domain-specific medical AI app. Now, you have to pre-train this, and you have to feed new knowledge into this LLM, every week, every month, whatever you have. So how they did this here in Stanford was clever. And they took this entity graph, and this is the secret how to build a large synthetic data set. Because they just identified the entities. They build pairs and triplets, and then ask here an LLM to generate new text explaining here how the specific entities relate and interact with each other. And this is the way how to can build a huge training data set from a very small data set and have an additional benefit of identifying the most important words and the most important new technical terms and how they interlink into the linguistic semantics of the text. So this means that they did not just feed new data into the LLM, but they provided a knowledge structure that the LLM, based on its pre-training, was able to absorb immediately. This is efficient. This is what I'm looking for, Priming. We can cope with priming here very easily because, you know what? This entity graph, you can think of, they built here a virtual knowledge graph. And with a knowledge graph, you achieve exactly what I showed you in my last video when I was talking about this new color here, vermilion. If you define it has a yellow hue, it's predominantly a bright red-orange color, and you identify the object it is going with, you have narrowed it down so much. This is exactly what happens in a knowledge graph. In a knowledge graph, you have the connection to the other nodes with your valued edges. You have edge features. You can narrow it down exactly, and this is what happened here already in October 2024 with Stanford. And they found a solution Google had no idea about when Google published this paper last week. So this, I think, is a beautiful idea. No? So this generated text focused explicitly on entity relationships turns out to be a very effective format for the LLM to learn the underlying knowledge during continued pre-training. And now, if you have seen my last video, you understand now why this is possible. The similarity here of the training data, of the pre-training data sets. And this is much better than just rephrasing the original documents, because it makes the implicit connection in the original text explicit and varied in the synthetic text and generates the right amount that we need for the pre-training. Because our pre-training methodology are different from the fine-tuning methodology and different from the reinforced learning methodologies. Now, since October 2024, Stanford published this, we have new tools. And I have here a video LLM plan on a graph. You have knowledge graph adaptive reasoning. Or if you like to go with UC Berkeley, I showed you here the new methodology called GIF, where you add an LLM to a knowledge graph and vice versa. Very interesting, I think, especially for the medical AI or medical agent, will be here this old paper where I showed you Harvard presents here exactly the fusion of a medical LLM and a new knowledge graph, how you can integrate now the new knowledge into the pre-trained knowledge of an LLM. If you have now an agent built around them, this can now be a real beautiful meta-AI agent. And of course, if you go here with graph rack systems, we built here a multi-agent graph rack here just about 2 months ago. So now we do have the tools. But you know what I want to show you is the inside. Because I learned something. Because I learned that now we have the pre-training, and this is done by the global corporation, and this is done over a month, so maybe half a year. This is done on 10,000 NVIDIA GPUs, 100,000 NVIDIA GPUs, and this is the pre-training. But if you want now to have a domain-specific knowledge on this pre-trained LLM, we go now with CPT. And now we understand how we have to do the CPT training. And if we have added here the latest knowledge, then we go to the supervised fine-tuning. Because supervised fine-tuning is different, and especially then to GRPO and DPO. So we are here not at the reasoning models. We are here not at inference time. We are not at test time scaling. We are here at the base for our reasoning models. We are here really in the research layer to build the next generation AI. Because now we understand, if you want to build here a medical AI that includes the latest knowledge from yesterday, up to yesterday, now we know how we have to build the training data set, and now we know how to build the training methodology. It will be a continued pre-training that makes the model more knowledgeable about a specific domain, integrating the latest knowledge. And now you might ask, and supervised fine-tuning? In my old videos, I'm much more precise in my wording. You remember when I told you fine-tuning on a downstream task? This is it. Fine-tuning makes the model skilled on one particular specific task, often leveraging the knowledge that it has to have to be able to do this task, to find variation to this task. So this is here the basis to go down and go in an ICU in a hospital. And if you have an AI performing here an operation, this operation and the task of this operation, this specific task you train on a supervised fine-tuning. But the latest knowledge about a medical AI, about human anatomy, about the procedures you're gonna take, this is happening here. And then we have the alignment, either GRPO, DPO, TPO, whatever you like. And then we can build our reasoning model with test time scaling. And you remember, just think about this beautiful example here, open source DeepSeek R1, the distillation models. And you remember that R1 told, DeepSeek R1 told us, supervised fine-tuning was essential before we started with the reinforcement learning for the smaller models. And if you want to see this in detail, here is the specific video for you, where I explain it. So if you want to see this here written out here, more compact, this is here for you. This is continued pre-training, incorporate the latest knowledge, make a real medical LLM update in knowledge with continued pre-training. Fine-tuning, you further train it now on a smaller task-specific data set. Teach the model how to perform here a particular downstream task to perfection. You do this in your data set that consists of input-output examples. And this is the way you teach the model how to do something real specific for a particular task, rather than you update the general knowledge. And of course, reinforcement learning model aligns better with the human processes. You use different reward models. I have, I think, more than a dozen videos on reward models. Outputs the reward model, scores them, and shapes the style and behavior of the model response. Great. You want to see this on a table? This is for you. Now you understand. This is now interesting. Né? Our continued pre-training now is the tool to add new knowledge to the LLM. Fine-tuning is the tool to go with a specific fine-tuning training data set with input-output examples for achieve here a task-specific objective, and you have simply a reinforcement learning here alignment, utilizing here a reward maximization optimization problem. You have these in sequential stages, and this is clear. Now let's look at the futures. Today we have our autoregressive next token prediction machine, and you know this is the transformer, the decoder part of a transformer, and we have a beautiful one-dimensional complexity. And if we have a complex problem and we can reduce the complexity into multiple smaller problems that we can further reduce to a one-dimensional complexity, this is the optimum case for our transformer. And maybe we can cheat a little bit to go 1 or 2 dimension higher, but in principle we have here a one-dimensional next token prediction, and that's it. Now you know that graphs, that I like graphs. I like graph neural network. I have more than a dozen videos on graph neural networks. I think going now here and adding a geometry to this is really helpful for AI reasoning. So I think the next step after the classical transformer will be something here with a higher geometry for geometry relations, features, and higher topologies. Or, and I'm not sure about this, there's of course a layer that I wish I would already be there. As a theoretical physicist, I do have a bias towards quantum physics, quantum field theory, or in the simplest case, quantum mechanics, you know, that we have complete new geometries, that we perform our path integral, in our integration there, no? Because now where we have here our tensor calculation, and it's more or less just a matrix multiplication, but such in a simple space, because we're working here on a one-dimensional autoregressive next token prediction, that we lose the ability for higher complexities. Now, it's now too complex for this video to explain this, but a quantum computer would open up this complexity in the reasoning process. It would provide complete new tools for us to tackle higher dimensional, higher complex problems. So I think, hopefully, I will be able, if you want, that I can explain this to you. I can provide you with examples I can run maybe some experiment. I have access to quantum computers already, but this is quite early right now, so I'm not sure when this is gonna happen, because it's for right now, for my audience, I'm not sure if you would be interested, because you can't use this. If you don't have access to a quantum computer, what does it give you? So I will feature now here, I think my immediate future here on these 2 levels here. But just that you know, I'm looking forward here to the 3rd step, to the 3rd level, where we finally can talk about quantum computer and quantum computing AI. Coming back to Achilles paradox, you know, looking back now at this video, I can tell you, I'm pretty sure I'm the turtle in this idea, no? Because I will have to be always 1 step ahead of Achilles. But you know what? We can be proud of, because we, as a human civilization, we created AI. We created Achilles. We created a beast that will hunt us for eternity. And we created now a competition where we as humans always have to be 1 step ahead. So in a kind of, it is fascinating for me to understand that I have to learn faster. I have to learn better. I have to read more. I have to understand more. I have to be able to communicate better. I have to be more focused, providing values. But yeah, maybe it is not that easy, because, you know, I'm just a simple YouTuber, but I would love to provide here more value to you. So if you are interested here in the future of this YouTube channel, hey, why not subscribe? And I see you in my next video.